Welcome back, everyone. This is topic 8 in wine additions, video number 2A, and we are going to talk about adding SO2. Let's get going. I want to review the common practices for SO2 additions and then give some background for calculating the concentration of molecular SO2 in a wine. Calculating the concentration of molecular SO2, and that'll make a lot more sense after the next couple of videos. We're going to start in this video with when we do the calculation, how to set targets for the concentration of molecular SO2, and estimating the amount of bound SO2 for any SO2 addition. That'll make more sense shortly. So remember, this was our roadmap to our SO2 discussion. We started out in video number 3 or lecture number 3 with some introduction. Then we went on to talk about common practices in the timing of additions. We talked a little bit about natural and organic wines. And then in 7A, the wine chemistry lecture, part of the wine chemistry series of videos, we talked about free and bound SO2, the 3 species of SO2, and the importance of molecular SO2. So you are now in lecture 8. You are here. We're going to talk about calculating molecular SO2 and the steps that are required. We'll finish by methods of adding SO2 and some limits on SO2 additions. In this video, we're going to lay the groundwork for calculating the concentration of molecular SO2. So first, when do we do the calculation of molecular SO2? We talked about these common practices. We said at harvest you add a certain range of SO2 depending on the health of the grapes. We said at the end of primary, if you're not doing malolactic fermentation, you'll add some range. If you do malolactic fermentation, you'll hold off on SO2 additions until the end of malolactic and then add some range. During cellar aging, we'll often keep our SO2 concentration in some certain range, certain level. For example, when we top up barrels, we will add SO2 to get us up to that range that we're interested in. At bottling, that's the time we're going to be very aware of and probably calculate or target a concentration of molecular SO2. In these earlier additions up here, we added some range of SO2 that we know as a winemaker is going to give us pretty good protection against microbial spoilage or against oxidation. But at bottling, that's when we want to think about the target for molecular SO2. Because remember, molecular SO2 is the species, remember there are 3 species, and molecular SO2 being one of the 3. It's the one that has antimicrobial properties. So we want to make sure that we have enough molecular SO2 that we're protecting against any microbes that might cause spoilage. All right, that's the key. Making sure we have enough molecular SO2 to protect against microbes that might cause spoilage. So how do we set targets for concentration of molecular SO2? Again, we're trying to target some concentration to prevent any spoilage that we're worried about. Say we're worried about spoilage by Saccharomyces cerevisiae. All right, that's our regular wine yeast. Perhaps we leave a little residual sugar in the wine at bottling. Consumers often like a little sweetness, just a little bit. But if there's Saccharomyces cerevisiae cells present and there's sugar present, fermentation can happen in the bottle. So how would we prevent that? Well, 0.8 parts per million of molecular SO2 inhibits fermentation by Saccharomyces cerevisiae. Won't kill the cells, won't prevent it forever, but it will inhibit it. So if we don't filter our wine, there will be some Saccharomyces cerevisiae cells in the wine. And if there's sugar present too, we could have a little fermentation in the bottle. So if we wanted to prevent that, we would make sure that we had 0.8 parts per million of molecular SO2 at bottling. Say instead we want to protect against Brettanomyces or wild yeast species or bacteria. The target there is 0.4 parts per million molecular. It's lower than the target for Saccharomyces cerevisiae because bacteria, most wild yeast species, and Brettanomyces are more sensitive to SO2 than is Saccharomyces cerevisiae. So we can get away with a lower level. Why would we want a lower level? Well, the less added sulfites, the less chance you're going to have some sensory impact from those added sulfites. Plus, you have the expense of the sulfites. Plus, people like wines these days that have less additives. So we usually go with the lowest level we can. But we're going to pick a target. If I'm worried about spoilage by Saccharomyces cerevisiae, I'm going to pick 0.8 parts per million as my target. If I am if I'm worried about spoilage by bacteria, say lactobacillus or something like that, I'll pick a target more like 0.4 parts per million molecular. So I have to do that before I make my addition because I want to know what my target is. One of the other things we have to consider is how much bound SO2 results from any addition. So I'm going to add SO2. How much will be bound? How much of that addition will become bound and how much will become free? Kind of looks like this. Say on the left here, we start out with a wine. And this is a wine that has a whole bunch of molecules floating around in it. And they're represented by these small circles. So there's some molecules that are represented by red circles or blue circles or orange circles. Say we add SO2 then to that wine. And those SO2 molecules will be represented by these black circles. Well, some of that added SO2 is going to get bound up by the other molecules in the wine. So for example, on the right here then, the result, this is what results after the addition of SO2. We have some SO2 black circles that are actually bound to other molecules. There are other SO2 molecules that, when added to wine, are free. So it looks like here we have bound 1, 2, 3, 4, 5, 6, and free is 4. So we added in this example, this rough example, we had added 10 molecules of SO2, and 40% of them remained free, and 60% became bound. Why do we care? Well, free SO2 is the molecule that has antimicrobial and antioxidant properties. When SO2 is bound up, it's not active as an antimicrobial and it's not active as an antioxidant. So when we add SO2, we want to estimate how much is bound and how much is free, or how much will be bound, how much will be free after the addition. So we will estimate how much of our addition is bound versus free. And we guess that the range of free is usually between 1/3 and 2/3 of bound. And it depends on whether the wine is cloudy or clear. So if the wine is cloudy, we estimate that 1/3 of the added SO2 will be free. All right? So if the wine is cloudy, 1/3 of what we add will become free. If the wine is clear, 2/3 of what we add will be free, and only 1/3 bound. Now these are estimates. Every winemaker has their own estimates they use. These are guesses. These help guide us in how much SO2 we should add. We don't know exactly how much will be bound and will be free until we actually test the wine the day after the addition. But this gives us an educated guess. All right, so say we had a cloudy wine. Let's go ahead and let's take an example. 30 parts per million SO2 added to a cloudy wine. All right, so in cloudy, any addition in a cloudy wine will end up being 2/3 bound and 1/3 free. So we add 30 parts, and we know that 2/3 of that will be bound. So we expect, we don't know, we guess, we make an educated guess that 20 parts per million, or 2/3, will be bound, and 10 parts per million will remain free. And why is that true for a cloudy wine? Well, there's a lot more in the wine that's capable of binding the SO2 because the wine's cloudy. In a clear wine, there's a lot less to bind the SO2, and so more will remain free. But in a cloudy wine, that's about what we'd expect. And so those are our guesses. This is going to be important in the next video when we actually calculate the addition of SO2 to yield a certain concentration of molecular SO2. Again, in the next video, we'll talk about this will become important to estimating the amount of SO2 additions that become bound versus free. In that next video, we are going to see these steps. These are the steps for calculating SO2 additions in order to yield a target concentration of molecular SO2. So we just talked about steps 3 and really step 6 in this video. We talked about determining the target level of free SO2 depending on what you want to inhibit, yeast or bacteria. And we talked about estimating the percent free in any addition, and that ranges usually from 1/3 to 2/3 of bound depending on how cloudy the wine is. In the next video, we'll pick up those 2 steps and incorporate them into this list of 8 steps for determining how much SO2 to add in order to reach a target concentration of molecular SO2. See you in the next video.